And these, my friends, are but the blueprints for the tales yet to be told.
In the modern world, construction is a complex, mechanized process where every step is calculated down to the millimeter. We are used to heavy equipment, laser levels, powerful cranes, and fast tools that make work easy and quick. It is difficult for us to imagine how massive cathedrals and impregnable castles could have been built without all of this. But in the English Middle Ages, builders had to do without electricity, gasoline engines, and steel. Their tools and methods seem primitive, but the results of their labor are still impressive. The grand structures of that time have stood for centuries, withstanding the test of time and the elements. Their tools were simple but effective, and their construction methods were logical and consistent. Watch the video to the end to find out how ancient builders created architectural masterpieces using only stone, wood, and their own minds.
And with these, we will build a stronger foundation for our city.
The first thing that comes to mind when we talk about medieval buildings is stone. Huge, heavy blocks that make up the walls of castles and cathedrals. But how were they lifted and processed without heavy equipment? First, the stone had to be extracted. The main method was manual extraction in quarries. Workers used wedges and hammers to split the rock. They found natural cracks in the rock, drove wooden wedges into them, poured water on them, and the wood swelled and broke the stone. It was a slow and laborious process, but it allowed blocks of the required size to be obtained. This method was based on knowledge of the properties of wood and its ability to expand in volume. It was safe as it did not require explosives. Next came the processing stage. First, the stone was roughly shaped with a chisel and hammer, then more precisely using various types of chisels and gouges. For the final polishing, a grater and sand were used. The most amazing thing is that the craftsmen used only ropes, plumb lines, and wooden squares to check the flatness of the surfaces and angles. No laser levels or measuring instruments. This required incredible skill and a keen eye. Each stone was fitted to its neighbor with jeweler's precision. However, there were nuances here as well. Even today, we admire how sturdy medieval walls are. But why are they so strong? It is not only the skill of the masonry, but also the mortar itself. Medieval mortar, like its modern counterparts, consisted of a mixture of sand and lime, but its strength was at a level that is not always achievable today. The craftsmen of that time had a deep knowledge of the properties of materials. They intuitively understood how various additives could affect the final result. For example, horsehair or straw was added to the mortar to increase its plasticity and prevent cracking. These organic fibers acted as reinforcement, binding the mortar together and preventing it from breaking under load. This simple trick made the mortar more resistant to deformation and temperature changes, which was especially important for massive walls. To make the mortar more water-resistant, builders could add various organic materials containing fats or proteins. These additives helped create a denser and less porous structure, which prevented moisture penetration and masonry deterioration. In addition, it is known that for some particularly important structures, lime was added to the mortar, which was slaked for years and sometimes even decades. It was believed that the longer the lime was left to stand, the better and stronger the mortar would be. This was not just construction, it was art. Bricklayers and mortar masters worked closely together to achieve the perfect result. They understood that every component mattered. To obtain lime, workers burned limestone in special kilns. This process was laborious, but it was necessary to create the main binding component of the mortar. The lime was then mixed with sand and water to achieve the desired consistency. Sometimes clay was added to the mortar to make it more viscous and easier to work with. The composition of the mortar varied depending on the region and the availability of materials. In coastal areas, sea sand was sometimes added, which contained salts that also affected the strength and properties of the mortar. These experiments, based on empirical knowledge and many years of experience, led to the creation of unique mortar recipes that still amaze modern engineers. By adding materials to the mortar that might seem strange, craftsmen achieved remarkable results. We have three versions of what was added to the solution: egg white, milk, or blood. Write in the comments which of these options seems most plausible to you, and in the next chapter, we will reveal the real secret of medieval builders. Wood played no less important a role than stone. It was the main material for scaffolding, roof trusses, roofs, and floors. The choice of wood was critical. Oak was commonly used because of its strength and durability. Trees were cut down by hand using axes and saws. The saws of that time were primitive, a thick blade with few teeth. Sawing logs into planks was very laborious, requiring the efforts of two people, one of whom was in a pit under the log. Wood was also processed by hand. Axes, adzes, and knives were used for this purpose. Carpenters had to not only be able to shape the wood, but also know how to prevent it from cracking and warping over time. Wooden elements were fastened without nails or screws. Instead, they used mortise and tenon joints, wooden pegs and ties. These methods were extremely reliable and allowed for the creation of sturdy frames that could withstand heavy loads. To erect tall wooden structures, builders used amazing mechanisms, many of which were based on the power of levers and block systems. One of the most common methods was the use of lifting wheels driven by people. Inside such a wheel were workers who, walking along its inner surface, caused it to rotate. A thick rope was wound around the wheel shaft, to which a load was attached. Although slow, such mechanisms made it possible to lift even the most massive oak beams to great heights. Another important device was the winch. This was a more versatile device that was driven by levers rather than human power. It consisted of a drum onto which a rope was wound. Using levers, workers could slowly but surely lift heavy logs. Winches were often used in combination with block systems, which made it possible to increase the lifting force many times over. The use of multiple ropes and blocks also helped to distribute the load, making the process safer. Simple levers and rollers were used to move large beams horizontally, for example, at the top of a wall. Workers placed round wooden rollers under the log and used levers made from other logs to roll it into the desired location. This required synchronized effort and precise coordination, but allowed very heavy loads to be moved without the use of complex machinery. In addition to lifting mechanisms, the scaffolding we mentioned earlier was also part of this complex system. It was built from the same logs that were later used for construction. The scaffolding was a complex frame of vertical and horizontal beams fastened together. They served not only as a working platform, but also as guides for the lifting mechanisms. In simple terms, scaffolding was not just an auxiliary structure, but an integral part of the entire construction process. By the way, to connect wooden elements, builders used surprisingly complex and reliable joints that could withstand enormous loads without a single nail. This was necessary because nails at that time were very expensive and not always durable. But how did builders lift huge logs to create roof trusses? Even today, a crane is used for this, but back then, it was done by hand. Let's talk about that now. Lifting heavy loads, whether stone blocks or massive beams, was one of the most difficult tasks. But the builders of that time invented a number of ingenious devices to make this work easier. One such mechanism was the trebuchet, or throwing machine. Yes, you heard right. The same mechanism that was used to besiege fortresses was also used in construction. Only instead of stones, it threw beams and loads that needed to be lifted to a height. Another important tool was the well wheel. This was a huge wheel inside which a person moved, creating traction. Through a system of blocks and ropes, it could lift heavy loads. This principle was used in hoists, which were used to move stones to a height. Of course, it was slow and required a lot of strength, but it allowed you to work with enormous weights.
But we are almost there.
Builders also used winches. A winch was a drum onto which a rope was wound. It was driven by levers or manually. This mechanism allowed heavy objects to be lifted to a small height and moved horizontally. And of course, the main tool for lifting loads remained block and rope systems, which allowed for a significant increase in human strength. In addition to the above, builders used simpler but no less effective devices. For example, wooden levers were used to move large stones over short distances, especially on uneven ground. With their help, even the heaviest boulders could be moved and slightly lifted. For the same purpose, wooden rollers were actively used, which were placed under the load to reduce friction and facilitate its movement. This method, although primitive, was extremely effective for transporting massive stones from the place of processing to the place of laying. One of the important inventions that allowed loads to be lifted accurately and carefully was a hand-operated winch crane. This device resembled a modern crane, only in miniature and without a rotating boom. It consisted of a wooden frame to which a winch was attached. This mechanism was often installed at the top of an erected wall or tower, allowing building materials to be lifted directly from the ground. This design saved time and effort, as there was no need to move materials along long ramps. Special wooden lifting frames were used to lift particularly heavy and bulky objects, such as massive beams for roof trusses. These structures, assembled from sturdy logs, could withstand heavy loads. They worked on the principle of a lever and were often operated by several workers at the same time. The entire system of lifting mechanisms was carefully thought out and organized. Interestingly, the effectiveness of these mechanisms depended largely on the quality of the ropes. They were made from plant fibers such as hemp or flax. The ropes had to be very strong and reliable, as they bore a huge responsibility. Before use, each rope was carefully checked for strength. Despite their apparent primitiveness, these mechanisms allowed medieval builders to erect structures that still amaze us today with their grandeur and size. Construction in the Middle Ages was a huge collective project. Large-scale works, such as the construction of a cathedral, could last for decades or even centuries. Hundreds or even thousands of people worked on a single site. Everyone had their own specialization: mason, carpenter, blacksmith, unskilled laborer. The work was clearly structured. At the head was a master mason or architect who planned all stages and supervised the work. The work site was organized in such a way as to minimize unnecessary movement and effort. Quarries, workshops, and warehouses were located near the construction site. This allowed for the quick delivery of materials and tools. Workers lived in tents or temporary structures right on the site. One important aspect of the organization was the division of labor. For example, masons worked in groups. One group extracted stone, another processed it, and a third laid it. This allowed for high efficiency. The working day was long, from dawn to dusk, but it was interrupted by lunch and short breaks. Workers were paid for their labor in the form of food, housing, or small amounts of money. In addition to the main workers, there were other specialists on the construction site who were indispensable. For example, blacksmiths provided builders with the necessary tools. Their workshops were located right on the site so that they could quickly repair and manufacture hammers, chisels, saws, and other tools. Carpenters not only processed wood, but were also responsible for erecting scaffolding, formwork, and roof trusses. Their work was no less important than that of the masons. Stonemasons also played an important role. These were highly skilled specialists who were engaged in the final processing of stone, creating decorative elements, columns, and statues. Their work was very painstaking and required incredible skill. Each element of a cathedral or castle had its own drawing, which the stonemason transferred to the stone. In some cases, the drawings were made in full size on a large piece of wood or on the ground. Another important aspect of the organization was supply. Materials were delivered to the site in various ways. Wood was brought from nearby forests on carts. Stone was brought from quarries, which were often located not far from the construction site. The organization of the delivery and storage of materials was a separate task that was handled by the people responsible for it. Work on the construction site was very hard and required not only physical strength, but also endurance. Workers began their day with the first rays of the sun and ended it at sunset. But despite all this, the work was well organized and structured. Everyone knew their task and worked as a team. This was necessary to achieve the common goal. At the same time, special signaling systems were used on large projects to coordinate actions. For example, the ringing of a bell could mean the beginning or end of a break, and a specific horn signal indicated the start of lifting heavy loads. This allowed the actions of hundreds of people to be synchronized and accidents to be avoided. What do you think the builders used to measure time? We'll talk about that in a minute. Medieval construction was not just work, it was a craft. The secrets of the trade were passed down from generation to generation. Builders did not just blindly follow instructions. They used their experience and intuition. For example, when working with stone, they could feel how it would split and knew where to strike to get the desired shape. They knew which stone was best for foundations and which was best for fine carving. One of the most amazing examples of their skill are the buttresses, massive supports that held up the walls of the cathedrals. They were not simply made of stone, but of elements that were carefully fitted together. The masons knew how to calculate the weight that would be placed on a buttress and how to install it so that it could withstand the load. Their knowledge was more intuitive than theoretical, but it was incredibly accurate. Another example of their skill was the use of flying buttresses, half arches that supported the vaults of cathedrals. Their construction required not only strength, but also precise calculations to ensure that they could withstand the lateral pressure of the vault. Medieval craftsmen knew how to design these structures, relying on their experience and knowledge. They created full-scale drawings on wood or on the ground to accurately calculate all the proportions. The masons of that time were often sculptors as well. They did not just cut the stone, but also carved decorative elements, statues, and gargoyles on it. These elements, in addition to their aesthetic function, also had practical significance. For example, the gargoyles we see on medieval cathedrals are not just decorations. They served as drains, diverting rainwater away from the walls to prevent them from collapsing. This is another example of the ingenious practicality of medieval craftsmen. The craftsmen used not only their knowledge of stone, but also their knowledge of geometry. They had a perfect understanding of proportions and symmetry. To create perfect arches and vaults, they used a compass and a string. With these simple tools, they could draw perfect circles and measure angles. This required not only skill, but also an amazing sense of form. Every element of the structure was calculated and verified with a precision that seems incredible for that time. Special attention was paid to the keystone, a wedge-shaped block that was placed at the top of the arch or vault. Its installation was the culmination of the work on the arch. The keystone held the entire structure together and gave it strength. Without it, the arch would simply collapse. Master builders knew exactly how to calculate the shape and size of the stone so that it would fit perfectly into its place. The secrets of the craft were passed down from master to apprentice. It was a kind of secret guild where knowledge was kept from outsiders. A master who trusted his apprentice could pass on all the intricacies of the craft. This allowed unique technologies to be preserved and developed. The apprentice started with the simplest tasks, gradually moving on to more complex ones. Only after many years of training and practice could he become a master himself. This process ensured that knowledge would not be lost and would be passed on to the next generation. This system of training and passing on experience allowed medieval builders to not just copy other people's work, but to create new, unique masterpieces. They constantly experimented with materials and designs to make their buildings even stronger and more beautiful.
We must adjust the north transept. The original plan will not bear the weight.
One of the most impressive examples of such craftsmanship is Lincoln Cathedral, which is said to have been built according to the principle of living architecture. The craftsmen who worked on it constantly made changes to the design based on their own experience in changing conditions. They could change proportions and shapes to achieve the best result, which made each building unique. In addition, craftsmen often left special marks on their work, stonemasons' marks. These marks, similar to initials but with a more complex shape, helped identify who had carved a particular stone. They were a kind of signature, confirming the quality and skill of the craftsman. These marks still help historians today to understand how work was organized on medieval construction sites. They testify to the high status and pride of the craftsmen in their work. It was not just a job for pay, it was a calling. The scaffolding used for construction in the Middle Ages was very different from modern scaffolding. Instead of metal pipes, wooden beams were used, which were connected with ropes or wooden wedges. The erection of scaffolding was an art in itself, requiring skill and experience. The scaffolding had to be strong enough to support the weight of the builders, tools, and materials. For the construction of tall structures, scaffolding was built in tiers. As the building grew, the scaffolding was extended. Ladders were simple, made of logs. Sometimes inclined ramps were used to move materials. All elements of the scaffolding were very securely fastened because the safety of the workers depended on it. In addition to scaffolding, temporary wooden frames called formwork were used to build vaults and arches. They served as a mold onto which stone blocks were laid. After the mortar hardened, the formwork was dismantled. This process was very complex and required precision. The craftsmen had to correctly calculate the curvature of the arch and create formwork that replicated it. This was one of the key stages in the construction of arches. Working with wooden scaffolding required not only physical strength, but also a deep knowledge of the properties of wood. The carpenters responsible for erecting it had to be able to select the right logs and calculate their length and thickness so that the structure could withstand the necessary load. Not only ropes, but also wooden wedges and spikes were used to connect the scaffolding elements. This made it possible to create strong, stable, and yet collapsible structures. An important aspect was that scaffolding often served not only as access to the upper parts of the building, but also as a base for lifting mechanisms. They were used to install winches, hoists, and block systems, which were used to lift heavy stones and beams. This integration of scaffolding into the overall construction system made it an indispensable element of any large project. Formwork, in turn, was a true work of carpentry art. The master carpenter who created the formwork had to possess not only skill, but also knowledge of geometry. He used a compass and a ruler to draw the outline of the future arch on the ground or on a large piece of wood. Then, following this drawing, he cut and joined the wooden elements, creating an exact copy of the vault or arch. The quality and accuracy of the formwork determined how strong and stable the stone structure would be. Once the formwork was ready, the masons began laying the stones. They laid the blocks starting from the base and moving toward the top. The formwork supported them until the keystone was laid, the final wedge-shaped block that held the entire arch together. After that, the formwork was carefully dismantled and the arch stood on its own. It was this process, requiring incredible precision, that was one of the main secrets of medieval construction. But how do you think they managed to make the arch perfectly symmetrical? Keep watching the video to find out. The medieval builder's toolkit was simple but effective. The main tool was a hammer. It could be of various shapes and weights depending on what it was used for: splitting stone, driving wedges, or working with wood. Another important tool was a chisel, a tool with a wide blade that was used to level stone. Various types of chisels, gouges, and chisels were used for more delicate work. These tools allowed the stone to be shaped, decorative elements to be carved, and blocks to be fitted together. Axes, adzes, and saws were used for woodworking. The quality of these tools depended on the skill of the blacksmith. Plumb lines, squares, and rulers were used to measure and check flatness. A plumb line was a rope with a weight at the end. It was used to check the verticality of walls. A square is an L-shaped wooden strip that helped to set right angles. Rulers were made of wood and had markings on them. They were not very accurate, but sufficient for the task at hand. In addition to these basic tools, builders had other, less obvious but equally important tools in their arsenal. Special abrasive stones and sand were used for grinding and polishing stone. Stone blocks intended for visible parts of the facade were carefully processed to give them a smooth and aesthetic appearance. This work was very laborious and required patience. Another important tool was a plane, which was used to process wood. The plane allowed for a smooth surface and high precision when fitting wooden elements together. It consisted of a wooden body with a sharp metal blade attached to it. Workers moved the plane across the surface of the board, removing a thin layer of wood. We must not forget the spatulas and trowels, which were used to apply and level mortar. These tools were simple, but their shape and size were carefully chosen to ensure convenience and efficiency in work. Trowels were made of wood or metal and had a flat surface. Trowels were wedge-shaped and were used to lay mortar between stone blocks. For marking and drawing, chisels were used, sharply sharpened metal rods. With their help, craftsmen applied markings to stone or wood before processing. These lines served as a guide for masons and carpenters, helping them to achieve the desired shape and size. All this work required incredible concentration and precision. Every tool, from a simple hammer to a complex plane, was the result of centuries of experience and refinement. They were made to be reliable and durable. The quality of the tools directly affected the quality of the work. Therefore, master builders took great care of their tools and tried to keep them in perfect condition. The strength of medieval buildings depended not only on the quality of materials and craftsmanship, but also on technical solutions. One such solution was the use of mortar. As already mentioned, mortar was made from lime and sand, but to make it stronger, certain components were added. For example, lime was slaked for a long time, up to several years. It was believed that the longer it was slaked, the better it became. Ash or other additives could also be added to the mortar to increase its strength. The second important aspect is the foundation. The foundations of medieval buildings were very massive and strong. They were laid deep into the ground to support the weight of the entire structure. Often, the largest and heaviest stones were used for the foundation. They were laid on compacted earth to prevent subsidence. The third secret is the ability to distribute the load. Medieval architects knew how to distribute weight so that it did not fall on a single point. They used arches and vaults which transferred the load to columns and walls, which in turn transferred it to the foundation. This made it possible to build tall and sturdy structures that could withstand heavy loads. To reinforce foundations, especially on unstable soils, builders could use wooden piles. These long logs were driven deep into the ground, creating a solid foundation for masonry. Piles driven into clay and moist soils did not rot without access to air, which made them incredibly durable. This method made it possible to erect massive structures, even in places where construction seemed impossible. An example of this technology is the construction of Westminster Abbey. In addition, internal ties were used to increase the stability and strength of the walls. Medieval craftsmen knew that a wall made only of stone could be less durable than a wall reinforced from the inside. For this purpose, they used so-called facing and infill. The outer and inner surfaces of the wall were laid out with carefully processed stones, and the space between them was filled with stone fragments, rubble, and mortar. This created a monolithic and durable structure that could withstand enormous loads. Another important element that increased strength was the corners and cross vaults. The corners of buildings, especially in castles and fortresses, were made of larger and stronger stones that were interlocked. This gave the entire structure additional rigidity. The cross vaults that we often see in cathedrals were not only beautiful, but also very practical. They allowed the weight of the roof and upper floors to be distributed across columns and pillars, freeing the walls from unnecessary load. This made it possible to create large openings for windows in the walls. Thus, the strength of medieval structures was the result not of a single solution, but of a whole complex of technical solutions based on a deep understanding of physics and the properties of materials. Builders of that time did not simply copy other people's solutions, but constantly experimented to make their buildings even more reliable and durable. Their knowledge and intuition allowed them to create structures that have survived the centuries and still amaze us with their monumentality. Medieval builders did not have modern tools for calculations, but they were well versed in geometry. They used simple but effective methods to create symmetrical and proportional structures. One such method was the use of a rope with knots. It was used to create right angles and measure distances. To create arches and vaults, they used compasses. A compass could be made from 2 wooden sticks joined at the center. It allowed them to draw perfect circles and arcs. This was very important for creating arches, which had to be precisely shaped. Another important tool was a measuring chain. It consisted of links of a certain length. The chain helped to measure long distances. But of course, the most important tool was the mind. Master builders had an amazing sense of proportion and were able to create harmonious structures relying on their eyesight and intuition. Master builders often used geometric principles based on simple numbers and ratios, such as the golden ratio. They believed that these proportions created harmony and beauty, which was especially important for the construction of cathedrals. For example, triangles were the basis for many structures. Using a rope with 12 knots, it was easy to create a right angle, which was critical for marking out foundations and erecting vertical walls. This method, known as the rule of 3-4-5, was used to create a right-angled triangle, which helped with alignment and positioning. Various methods were used to transfer drawings onto stone or wood. One of them was piercing. The master drew a picture on parchment or paper and then pierced it along the outline. He then placed the sheet on the surface of the stone and sprinkled charcoal dust through the holes. This left a precise outline of the future drawing on the stone. This allowed complex patterns and decorative elements to be transferred with high accuracy. Another important tool was a scale ruler. It was a wooden strip with divisions marked on it that corresponded to a specific scale. With its help, craftsmen could transfer drawings from paper to real life. This was very important for calculating the proportions and dimensions of each element. Master masons also used special templates carved out of wood or metal. These templates represented the outline of future stone blocks, arches, or vaults. The mason would place the template against the block and chip away at it along the outline to achieve the desired shape. This allowed for high precision and repeatability of elements, which was very important for the construction of massive and complex structures. Thus, medieval builders had a deep knowledge of geometry and skillfully applied it in practice. They did not simply construct buildings, but created masterpieces in which harmony and beauty were combined with remarkable strength and reliability. Their methods, based on simple but ingenious principles, enabled them to erect structures that still amaze us today with their symmetry and proportions. Today, many medieval buildings are being restored. The same methods and tools used centuries ago are used for this purpose. This allows not only to preserve architectural monuments, but also to understand how medieval craftsmen worked. Restorers study old technologies to achieve maximum authenticity. For example, the same lime-based mortar is used to restore stone masonry. The stones are processed by hand, and primitive mechanisms are used to lift them. This allows the same result to be achieved as in the Middle Ages. Today, when we look at grand cathedrals and castles, we must remember that they were created by people who did not have modern technology. Their labor, ingenuity, and craftsmanship are admirable. They built the world we live in and left us a legacy that will stand for many centuries to come. Modern restoration work is not just repair, but in-depth research. Before starting any work, scientists and engineers conduct a thorough analysis to understand what materials and methods were used. They study the composition of the mortar, the structure of the stone, and the characteristics of the masonry. Sometimes modern technologies, such as laser scanning and radiocarbon analysis, are used for this purpose. But the restoration process itself often takes us back to the beginning. To replace damaged stone blocks, restorers use stone from the same quarries as in the Middle Ages, if possible. This allows for a perfect match in color and structure. The stone is also processed by hand, using hammers, chisels, and gouges, just as it was hundreds of years ago. This approach ensures not only authenticity, but also durability, as manual work allows for a better understanding of the material and all its characteristics. Wooden structures are also restored using medieval methods. To replace beams or rafters, restorers use the same types of wood, and to join them, they use spikes and pegs instead of modern nails. This preserves the integrity of the historic structure and extends its service life. An important part of the work is the restoration of wooden scaffolding, which, as in the past, is assembled without a single metal fastener. The restoration process is a kind of dialogue with the past. It allows us not only to preserve a monument, but also to study the techniques and secrets of medieval builders. It is living proof that simple but ingenious solutions can be more durable than the most sophisticated modern technologies. Every restored stone and every replaced beam is a tribute to the people who built this world. Medieval builders left us not only grandiose cathedrals and impregnable castles, but also invaluable knowledge. Today we continue to learn from them, understanding that the basis of any strong and durable structure is not technology, but a deep knowledge of materials and craftsmanship honed over centuries. We learned how people built in the English Middle Ages without modern tools. They used stone, wood, and their own minds to erect structures that still stand today. Their skill and ingenuity prove that complex technology is not always necessary to create masterpieces. All it takes is deep knowledge, intuition, and years of experience. Working in conditions that seem unimaginable to us today, these people were able to create architectural wonders that amaze us with their strength, beauty, and harmony. Their legacy is not only castles and cathedrals, but also living proof of the power of the human spirit in ingenuity. Every element, from the massive foundations to the elegant arches, was the result of painstaking labor and precise calculations made without calculators or computers. This forces us to take a fresh look at what we consider progress. What other topics related to history or construction would you like to see on our channel? Perhaps you are interested in how ancient Roman engineers built their aqueducts, or how the Egyptian pyramids were constructed? Leave your suggestions in the comments and don't forget to subscribe to the channel so you don't miss any new videos.
What tales shall we explore then, I wonder?